Dear students, how are you all? How everything is going? I guess you were studying our online video topic for every chapter, and if there is a problem, you will discuss with us. Well, we are continuing the chapter 7, wave and sound, and we stopped our previous class in echo part, and we discussed the equation of echo, that was the distance between source and reflector is for echo is d is equal to vt by 2. Well, from here we start our class. First CQ we'll discuss. Raju was shouting in an open field, and suddenly he heard his shouting twice. Find the distance between Raju and reflector. Say here this temperature was 25 degrees Celsius. Here t is equal to 0.1 second, as I have told you the minimum distance. That's why d is equal to what? V is equal to c. I have to find the v. For finding the v, I have to come here. Now see here, then I will discuss it there. Variation of velocity of sound. We have to discuss this topic to find the answer of V. Okay. In air, velocity of sound is proportional to the square root of temperature. So that means V proportional to root over T. This T is absolute temperature. So from here we can write something like that. V1 by V2 equal to root over T1 by T2. Okay. Now here the temperature is not Celsius temperature. I have told you temperature is in Kelvin. This is called absolute temperature. The velocity of sound does not depend on the air pressure, but it is inversely proportional to the square root of the density of the air. Well, the velocity of sound doesn't depend on the air pressure, but it depends on the density also. So if there is water vapor in the air, the density decreases. hence velocity increases. Okay, what I've discussed, if vapor is present in the air, the density decreases, so velocity increases. Sound is a mechanical wave. It depends on the elasticity of the medium, the nature of the liquid, and the solid and liquid, it differs. Okay, so I will tell you the realistic value of sound in water and in iron also. Okay, there is a chart given in your book. Well, from here we have to discuss this issue. See, this is the issue. This is the equation. We should discuss the scenario to find the v. Well, see here. V1 is 0 degrees Celsius velocity. That means 330 meter per second. V2 is in that temperature velocity, 25 degrees Celsius temperature velocity. That means I have to find it, and T1 is equal to, I have told you this is absolute temperature. For 0 degree, the absolute is 273 plus 0 equal to 273 Kelvin. And for this one, T2 is 273 plus 25. That means 298 Kelvin. Okay. Now, V1 by V2 equal to T1 by T2. That means 330 by V2. This is our V. It's root over 273 by 298. So we have to find the solution of it. Well, you may also do it in your home on hand. So I'm showing you how to do it. Then V2 is equal to 298 by 273 into 330. So V2 is equal to, so 298 divided by 273 root over into 330, 344.78 meter per second. I should put the value here. You will find this scenario beside this thing, beside this math, or under this sort of thing here place, you might find it out. Okay, so we know D is equal to Pt by 2. This V is 344.48 to T is 0.1 for maximum distance by 2. So into 0.1 divided by 2, so 17.24 meter. There's the distance to find the length from source to reflector. Okay, that's how we should do this type of math. Well, now let's see the math again. Okay, we can discuss another math in this regard. Okay, at a certain place at a certain place, the temperature is in winter is 10 degrees Celsius, and velocity of sound is given. We can't do anything about it, it's just given. Okay, if the temperature is rise to 30 Celsius in the summer, what is the velocity of sound? So see the step again. Well, how can we do the math? Okay, so we know already v proportional to t. So far v1 by t1 equal to root over t1 by t2. So here given here T1 is 273 plus 10, that means 283 Kelvin. For V1 332 meter per second, then T2 is equal to 373 plus 30, that means 303 Kelvin, and V2 is equal to what? Now V2 is equal to root over T2 by T1 into V1. Okay, so 303 by 283 into 303 divided by 283 into 32 343.53. So V2 is equal to 343.53 meter per second. That's how we should do the math in this process. Okay, now uses of sound. Now the topic is uses of sound. We need not talk about the common uses of sound. To speak, hearings, songs, doctor hear the heartbeat, engineers hear the sound of instrument, etc. There are other applications of the sound which you may not have heard about previously. We could not see from outside of the feature of the growth of the wombs of a pregnant woman. This is not possible with the help of process called ultrasonography. So we have a question: what is ultrasono? Okay, we find the answer here. There's another issue, three-dimensional. There's another use of sound, three-dimensional seismic, 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 SURVYS service. Okay. Well, seismic service is done to explore the whether gas, and or oil present inside the earth. To do it, a small blast is done a little below of the earth. Sound of the blast hits the different layer of the soil and returned after reflection. The reflected wave is detected by a specific type of receiver named a geophone. Analyzing the information, a perfect three-dimensional picture of soil is formed, from which gas or oil is present or not is determined. Since we know that the position of the source of sound and geophone, the distance of different layer of soil can be calculated accurately from the time required for the sound to reach from source to geophone. So, and the question, what is geo? Okay, ultrasound cleaning. Sound. This is another use of sound. Ultrasound cleaning is used when we need to clean some instrument perfectly in the laboratory. The small instruments are immersed in liquid and subjected to the ultrasound wave, the vibration of which removes the dust. Okay. Third question, ultrasound cleaning. What do you mean by that? Okay. Now, another is musical instrument. Musical sound. We heard different kinds of sound. Some of those sounds are sweet and some of those sounds are annoying. The sweet sounds are the sound of musical instrument. Well, and the wave sound of some musical instrument as shown in the figure 7.14. You might show in your book. You can see that all them are periodic vibration. In a tuning fork, a perfect vibration is created, but in a musical sound, there are not only a single wave, many waves superposed one another to make a sound melodious. Among those characteristics of musical sound, the important are three. One, intensity. Intensity is measurement of how loud of a musical sound can be heard. Okay, and its unit is watt per meter square. So amount of sound energy that flows per second per unit area is called intensity. Okay, there is pitch. The characteristics of musical sound by which the sound of the some instrument is sometimes heard dull and sometimes sharp is called pitch. While some musical instruments sometimes becomes dull and sometimes becomes sharp. This is pitch. The pitch is higher, the sharper is higher. Okay. Then is timbre. Timbre, the characteristics of sound by which we can differentiate the sound produced from different musical instruments is called timbre. The characteristics of sound by which we can differentiate the sound produced from different musical instruments is called timbre or quality of sound. The timbre is the quality of the sound that can measure as the different instrument differs different type of sound. It gives different type of sound. Okay. We will read this topic. It might sometimes comes in your question pattern in A or B. And finally, the sound pollution. So we all know the sound pollution, the irritating sound and the melodious sound. The sound is polluting in our urban areas and our local areas. The car, the bus, the industry, they are responsible to polluting the sound. And in your book, there's a table given, table 7.02. In this table, the intensity of sound of different type of things is given. This gives us the softness or irritable things in our hair. Okay, that's all for today. Tomorrow, next class, we'll discuss some creative question on this regard. Okay, till then, be safe. Allah Hafiz.